Hello everyone, welcome to Merrimack's STEM Academy. Today we're going to talk about periodic trends. Periodic trends explain chemical reactions and why molecules behave the way they do. And for those of you taking AP Chem, understanding periodic trends will help you justify your responses. So let's get right into it. First, we're going to talk about atomic radius. How do we measure atomic radius? It's half the distance between two elements bonded together. On the periodic table, as we move down a group, the atomic radius increases. Why does this happen? Let's take a closer look at group 1. Hydrogen has 1 electron shell. If we move down a period, lithium has 2 electron shells. Moving down another period, a sodium atom has 3 shells. The more electron shells in an atom, the larger the atom is going to be. So, as we move down on the periodic table, the atomic radius increases. Moving left to right, the atomic radius decreases. As we move from left to right within a period, the elements have more protons. For example, lithium has 3 protons, beryllium has 4, boron has 5, carbon has 6, and so on. As we increase the number of protons, the nucleus will have a larger positive charge, which will attract the electrons more. This causes the electrons to move closer to the nucleus, making the atomic radius smaller. To summarize, the atomic radius will be the largest in the lower left-hand corner of the periodic table and the smallest in the top right. An easy way to remember this is the saying low, left, large. Ionic radius is pretty similar to atomic radius, but it measures the size of ions instead of neutral atoms. As a reminder, ions form when atoms gain or lose electrons to form charged particles. On the left side of the periodic table, the atoms will lose their valence electrons to form positively charged cations. Group 1 metals have 1 valence electron that they lose, so group 1 ions have a +1 charge. Group 2 metals have a +2 charge. Elements in group 3 have a +3 charge. Group 4 have 4 valence electrons, so they don't usually become ions. And transition metals can form cations with different charges, so we won't talk too much about them. Elements on the right side of the periodic table gain electrons, forming negatively charged anions. Group 5 has a charge of -3, Group 6 has a charge of -2, and Group 7 has a charge of -1. Noble gases have a full valence shell, so they're happy as they are and don't form ions. As we move down a group, ionic radius increases. Just like with atomic radius, as the number of electron shells increases, the ionic radius will increase. But what about moving left to right on the periodic table? Well, that's where things get a little tricky. To explain what's going on, let's look at an isoelectric series. An isoelectric series is basically a series of atoms of different elements that all have the same number of electrons. For this series, we're going to look at atoms with 10 electrons. Neon, in its neutral state, has 10 electrons. A neutral fluorine atom has 9 electrons, so when it gains an electron to form the fluoride ion, it has 10. When oxygen forms an ion, it gains 2 electrons and has 10 electrons total. The sodium ion and the magnesium ion also have the same number of electrons. If we look at our isoelectric series, we'll see that the sodium and magnesium ions completely lose their n=3 shell, which makes them much smaller. Looking left to right across our isoelectric series, we can notice that although the atoms have 10 electrons, the cations on the right have more protons than the anions on the left. Just like with atomic radius, the more positive charge in the nucleus, the more the nucleus is going to attract the electrons and pull those electrons toward the nucleus. This makes the ionic radius smaller. In general, within a period, cations are smaller than anions. Let's take another look at the periodic table. Moving from left to right across the cations, the positive charge in the nucleus increases, so the ionic radius decreases. When we switch over from cations to anions, there is a big increase in atomic radius. This is because the anions have a whole electron shell more than the cations. As we move to the right across the anion, the ionic radius decreases, as the atoms have more protons and gain fewer electrons to become ions. Alright, that was a lot of information to process at once. Let's take a quick second to summarize. Atomic radius increases as we move down a group and decreases when we move to the right across a period. Ionic radius also increases as we move down a group. As we move to the right, it decreases, then increases as we switch from cations to anions, and then decreases again. Ready for a quick question to apply what you've learned? Here goes. Which has a stronger ionic bond, sodium chloride or potassium chloride? Pause the video here and think about it. Think you've got the right answer? Let's talk it through and find out. Each compound is made of two ions, sodium and chloride or potassium and chloride. To find out the bond strength, we need to look at the relative sizes of the ions. Both molecules have the chloride ion, so we're going to compare the sodium and potassium ions. The sodium ion is higher on the periodic table than the potassium ion, so the sodium ion is smaller than the potassium ion. So, because sodium has a smaller radius, when the sodium ion bonds to the chloride ion, the ions can be closer together. What does that mean in terms of bond strength? Well, according to Coulomb's law, the force is proportional to the product of the two charges divided by the distance squared. Basically, the force or bond strength increases as the distance between the ions decreases. Since the sodium and chloride ions can be closer together, they will have a stronger bond. Thank you for listening. Let us know in the comments if you have any questions and we will do our best to answer. Please like this video and subscribe for more videos about chemistry, biology, and everything STEM related.